Hi, Year 12. Hope you're doing well, had a good weekend. I'm just going to go through a few questions, just one little video per question to be able to go over some of the things about quadratic models. Basically, whenever you have a situation of something traveling through the air over time, it's a quadratic model. If you want to maximize space when you have a fixed outline or an outward bound and you have to maximize the space, that's a quadratic problem. There's many different areas actually where you find that it's a quadratic type modeling situation where we use these parabolas that we're able to go through and kind of look through that. So I want to just run through a few questions and examples and give you a sense of what we have. So we're going to finish off the exercise 8A and then start on 8B, and then later this week I'll spend a bit more time talking about a couple of things. But the first question I just want to look at is from this is exercise 8A, question 10. So we have this parabola here. It's concave down. And so we just want to go through and look at all the different parts to refresh what it is that we have. So the coordinates of the turning point. So if we remember, the turning point, otherwise known as the vertex, is where it turns around. All right, it turns around here. And the coordinates of that is x equals -2. And it's halfway between 8 and 9. So -2, 9. Is off the graph, and I think that should be correct, and yeah, it is, but that's okay. So the idea is that I can verify that from the function, from the y equals -x squared minus 4x plus 5, but that's the turning point. So -2, 9, otherwise known as the vertex, is also a word that's often used for that. The equation of the axis of symmetry. Now, axis of symmetry, where it is a mirror image on each side, and it always goes through the vertex. So the axis of symmetry always goes through the vertex. And another interesting point that I just want to point out here. Oh, and by the way, vertical line. So the equation of this is x equals -2. X equals -2. Equation of the vertical line. So it's always, a vertical line is always x equals something. And this one, it goes to -2. So that's the equation of my vertical line. So the equation is x equals -2. Now, notice that the distance from the axis of symmetry to one x-intercept is the same as the other one, right? In this case, it's 3 units and 3 units. It's going to be important to a later question that we do. Let's move to 3. The coordinates of the y-intercept. The y-intercept is where we cross the y-axis. In this case, it's here. Another way you can find it is, well, obviously, this is a more graphical approach. So the y-intercept, you can either say, it's good to give it as a coordinate, so it's 0, 5. So that's the coordinates of the y-intercept. The coordinates of the x-intercepts, you notice here, we can see those, I'll put those in green. One passes through the x-intercept here, and the other one passes through here. That's the x-intercept. X-intercepts. And so those are, well, 1, 0, always give it as coordinates, and -5, 0. And remember, they are equal distance. This axis of symmetry is halfway between the x-intercept. All right. Now the value of y when x equals -1. So x equals -1 is here. Change that to red. X equals -1 is here. And if we go up the curve, we go up, keep going, and we hit the curve here, it is in fact 8. So when x equals -1, y is equal to 8 is what we have, all right? And then the maximum value of the quadratic relationship, the maximum value of y is what we're talking about. So this is the maximum value of y. And this, the curve is going up, reaches its maximum point, and then goes down, 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 down. And so the maximum value is 9. Is y equals 9 is the maximum value, which is also the vertex. All right, so the vertex has very important position in all this stuff. So that's the first one to remind us a few things. The vertex, the x-intercept, the y-intercept, the axis of symmetry, making sure that we do that. Okay, thanks.